We are not live? Yes, we are live. Excellent. All right, so I am going to walk through an installation of the Crunchy Data Postgres operator for Kubernetes, and I'm going to do that on my terminal using Minikube. Let's see, switch to a terminal and get a new one. I'm going to make it bigger and full screen. So what I'm going to do is, the first thing I'm going to do is I'm going to switch to my Postgres operator. Go path, source, crunchy data, whoops, no, GitHub, crunchy data, Postgres operator. I'm going to go back to master because there we go. Then I'm going to say Minikube status. I don't have a current Minikube instance running, so I'm going to go ahead and do Minikube start. You should be able to install this on any kind of cluster. I just used Minikube because it's free and it runs on my machine, and so far I haven't really run into space issues with it. This takes a while. So the Crunchy Data operator has an installation page. There are deployment scripts for GKE or OpenShift clusters, but that is not going to be our situation, so we are going to go and use the manual installation. For the manual installation, we kind of want to go ahead and we need to set a couple of environment variables. Some of these are just already set by default of you having your Go path set, but this assumes you don't. The first steps I've already done. You go to your Go path, you put the operator in the correct place, and then interesting. And here, one of the first things I want you to do is do a git checkout. Let's see, how far is my Minikube instance going? I can actually just go ahead and open another terminal window. Do that there. Okay, git checkout 3.0. What this does is it gives me a stable version of the operator, and that way I don't run into test patches or alpha versions, which is actually quite important because at this point in time, the 3.0 version has been very recently released, so if you don't want any last-minute wrinkles, go ahead and use the stable branch, the tagged branch. All right, so the other thing you need, other than a working Kubernetes cluster and kubectl setup, and then there's a couple of environment variables that you're going to need. So the basic installation, we can ignore most of this. Because I'm installing this operator on Minikube, I don't need to worry about persistent volumes because it's just going to use the default host path on Minikube. However, I'm going to export some of these environment variables because the scripts and makefiles that the makefile is going to run need them. So I need the namespace, the demo namespace for the purposes of running this demo. I need the command equals kubectl, which is also an environment variable, and the co root path is one that we use here. So I copied the path. I copied the repo in the exact same path, so it's not any different. Where's my Minikube? It's taken forever. Okay, that's fine. I'm just going to let that go and go ahead and export these. Import. Levers. These. Cool. And then, and here it says build images and deploy. What we're going to do is we're going to use the packaged images to pull the images that the operator uses to create the operator. and then we are going to call make on it. The other thing that I have already done is the other thing that the Postgres operator has is a command line tool called PGO, Postgres operator, and you just go and download the binaries the way that you would any other binary. However, there's a little bit of a difference in the sense that when you unzip this tarball, it creates 3 different binaries. It creates one for Linux, one for Mac, and one for Windows. And they all have different names. So you just kind of have to realize that this particular demo walkthrough only talks about the Linux version of the command. I'll show that to you in just a second. Right here, if we go which PGO, it's in user local bin, but if I call file on that, I think that's the command, it does not run on my Mac. So the binary in question, and there's kind of nothing in the documentation that tells you this, you just kind of have to look at where you unzipped it and find it. It's called PGO-Mac. And then if we run file on that, now we can use it. What this particular command line tool does is it will basically help you set up the database, and you're also going to use it when you back up the database. But before we can set up anything, we need to have a working operator deployed on a working cluster.
The PGO is it in charge of installing the CRDs and all the other jazz, or is it just
It is just interacting with the installed operator. Yes.
After that's installed.
Yes. Yeah, that's kind of the big thing. The 3 different things, the 2 different things we need is we need to have a Postgres operator installed on a running cluster, and then we need to have the PGO binary, the PGO tool interacting with the operator.
That's the main way in which they want you to interact with the operator.
Yeah, exactly. And that's how you set up your database. That's how you back up your databases. You can get information on your databases. It's actually really powerful. It can show you the secrets of the databases. You can configure users. You can do a lot with it. And because it's so powerful, the way that I set up this demo is that for the app that will access the database, we will have an init container that literally just sets up the database and installs PGO and sets up the database so that the app container itself doesn't actually have access to PGO. Because users don't need that kind of power. Only database administrators do.
Cool.
So now we have a Minikube cluster, so I'm going to go ahead and check on the nodes. And there we go. I'm also going to alias out my kubectl because that's something that I ran into earlier. And then because of the demo, I'm also going to alias out the PGO Mac. There we go. So now what I'm going to do is go back to the installation instructions. I have the Postgres operator tool, and I'm going to export these 2 environment variables that the make file expects. And then I'm also going to call make both. So let me go here and just open the code so we can take a quick peek at the make file. Here's the make file. That away. So right here, there's a lot of options on the make file, not all of which I'm sure how to use. But you can see under make pull that there are 5 different images being pulled to build this operator. And it's using those environment variables that I just installed. So this is, I think, a monitoring pod. This is a tool that removes, I think, previous jobs. I'm not entirely certain. PGO load. And this is the operator itself. And then this is the API server, which is the way that the operator interacts.
Is that the main, that's the server side of PGO?
Mm-hmm.
Is that what that
Yeah.
is?
So after we do that, let's see how we're doing with the Docker pull, make pull. Awesome, image is up to date, fabulous. Now I'm going to hit make deploy operator. Actually, before I do that, one thing I need to do before, I believe, I need to go ahead and create the demo namespace. This is actually a really nice little tool. These are actually like 3 nice little steps. If you've ever gotten caught on using kubectl, find pods or get pods, -- all namespaces, it's a lot to type. This is how you actually just set the context to have the namespace of demo. And now anything, so now we've added a new namespace. And now anything that I look at in my Kubernetes cluster, if I go kubectl, get pods, it won't show me any pods because there's nothing in the demo namespace. But you'll see in a minute after I do that. Now I'm going to hit make deploy operator. Oops. I can totally type in front of a camera, I promise. All right, so the first thing that you're going to see is a bunch of error outputs. What this is actually just a cleanup script that runs before the make script. You'll see it'll check if all these things that it's going to install already exist. If they do, it will delete them. So if I hit make deploy operator again, what's going to happen is the first thing is they're going to be deleted. And yeah, so these errors are a little bit confusing at first. You're like, what am I doing wrong? And then at the bottom it says they're all being created. It's fine.
Guarantees clean installation every single
Yeah,
time.
it's just to make sure that we start from scratch every time. Now, if I go ahead and get the pods, I will see that the Postgres operator container is being created. So the next thing that I did, the next thing that we could do now is we could go ahead and port forward the service. Oh, here we go. There's a service associated with this operator. So if I go ahead and get the services, and keep in mind these are all in the demo namespace. Now we have a node port type service that listens at this port 8443. And what I can do is I could go ahead and port forward from that port to localhost and start using PGO and interact with it. What I did for the demo was spin up a demo pod from which to use the database to mirror kind of the use case of running an app inside Kubernetes that has access to this database. And this is what that looks like. So here I have a Docker file that literally just installs PGO and runs this script that makes a couple of commands here. So we have PGO create cluster, and I call it my cluster. And then it's going to show the cluster that has been created. I will go and show you where you can find the PGO commands. That's in the documentation. And then in the init, I have a pod. That's a Postgres operator. In the namespace demo. And I have 2 containers. I have the init container. And in the init container, that's where all the PGO stuff happens. That is where we're setting up the database in the first place. There are a couple env variables again, and you will see those as we go through the demo install as well. they are needed for some of the scripts. And then there's the PostSQL container, which literally just has Postgres installed on it. That's just a public Postgres Docker container. There are some secrets, which I can explain in a bit. These secrets will make it so that if I am in the PostSQL container accessing the PostSQL database, I'm already set up and I do not need to log in. So now I'm going to just run kubectl create -f init.yaml. Ooh, I forgot one thing. Another thing that is in the init YAML is a cron job, because we have a database. We want to back it up periodically. Currently, I have it set to run every 5 minutes, just for demo purposes. You wouldn't not actually want to have that many backups, but you can. This makes it so you can see it a little sooner.
Okay.
Question?
What image are you using for that?
Oh yeah, right here. This is the image. I'm using an image. It's called Gwen's Test right now. That's a terrible name. Do not use this name.
What is it?
And this is it. It is a CentOS base, and it installs PGO, and it runs the test script.
Okay. I see. Okay.
Yeah.
I see.
Interesting. That might actually be funny. It shouldn't run the test script on this one, but. Oh, the reason that works, actually, I should have used a slightly different image that doesn't have all the create cluster thing. The reason this actually works is because PGO create cluster, if the data cluster already exists, it's not going to do anything. That's the reason it works.
No, it's a no-op?
Yeah. Actually, I might want to... So this word cluster is actually confusing. And I should have gone over that first. I apologize. In Postgres, cluster is a word that means something historically that has nothing at all to do with a Kubernetes cluster. So when we say PGO create cluster, think of that as PGO create database.
The MySQL operator has the same.
Really?
The same exact issue.
They call it cluster as well.
Yeah, but they have a CR that is named MySQL cluster. That is in the MySQL. It's of the MySQL terminology and history.
Right.
Of how they set up
Yeah.
and make replication work.
Okay. Yeah.
So, same idea. Yep. The cluster, that cluster terminology is in the context of Postgres versus Kubernetes.
Right. So just I hope that I'm disambiguating enough in this case. So right here I'm using the same image that I used in the init container. So just so I would get PGO.
Sure.
But I was actually not being super careful, and I should have used a slightly more pared down one. But that's okay. It'll work for now. One thing I learned in this experience is what internal service names are inside a Kubernetes cluster. Right here, the service address for the Postgres operator is postgresoperator.demo, which is our namespace, .svc, which stands for service, and then .cluster.local. So that is a cool thing that I didn't really know exactly how to find before I did this demo.
Yeah, I learned something about that too. They shortened something down about that too.
Yeah.
Cut some of that off.
You can cut some of that off because there's probably only going to be one Postgres operator demo. A lot of the things at the end you can cut off. You can usually get by with just using Postgres operator.demo.
Service.
And it'll
namespace.
Actually, demo is the namespace. So namespace comes before.
That's what I mean.
You can skip the service even. I've used it successfully with this stuff.
Not
all
that
hacked off.
service. The service name. Service name.
Oh, yes, exactly. Service name.namespace. Yes. But I used the full one here because better be safe than sorry. Plus, it's kind of an official pod spec, so or job template spec, but whatever. All right, so now I'm running this script, and if I get my pods again, we can see that we have my pod, which is my operating pod, the Postgres operator is running successfully, which is great. And my pod, if we now follow some of the logs, my pod, and I want to see the init PGO. And right here, we see the output of that script. PGO lives in user local bin, PGO version. This is the check you use to see whether the client and the API server are talking to each other. And then it created a cluster. So now it's going to show the cluster. So hopefully what is happening, what PGO should have done, is create a Kubernetes pod that runs a database called my cluster. And there it is. Ta-da!
Almost ready.
Almost ready. And the MyPod container is currently just running Postgres, and it's kept alive by a Sleek script, just so I can exec into it and operate on my database.
Sure.
So now I have a really cool database, which is pretty great. And my Postgres pod, my pod, is already set up to talk to it. So what I can do is I can exec into it. I hope I'm doing this right. Hooray! Cool. So now I'm running in my pod, and I'm running PostSQL, SQL.
PGO. This is the guy that got PGO.
So this is PostSQL. This is the guy that has PostSQL in it. We already done with PGO.
Okay.
I'll walk you through what that container did in just a second with the install docs. I just want to show that the database is working. So here I can go PSQL-H, and then I'm going to use the service name, which is Postgres operator. Oh, HTTPS, I believe. Correct me if this is wrong. Demo. And then my user is Postgres. Not translate host name. Okay. So let's try. I'm having some access issues. I'm going to translate host name. Do I do this without the HTTPS?
Are you on the actual server?
I'm on the actual pod, on the Postgres pod.
Did you say localhost or something?
Localhost won't work because I'm inside my pod. I'm inside the same Kubernetes cluster.
Oh, you're in the pod, not the server.
Oh, here we are. That's the one, maybe. Network is unreachable. Interesting. That's a different error. How did I do this? Let me grab my notes really quick. I'm going to use. I'm very silly. So the Postgres operator is not the service we want. Let me exit really quick. We have another service right now. Now that we've deployed a database, we have a service called my cluster, which that is my database cluster. So really what I want to do is exec into my management pod, and then PSQL and into -h my cluster.demo. That's the one. Yay. Hooray! And now we're in Postgres. L. All right.
Select one.
Let's create a table for fun. Just for kicks. All right. And then insert. Oops. There you go. And then let's show the table. And there it is. And then we can add a different city, which is Gwenstown, which is way cooler than Janetown. And it is very easy to find. And I know nothing about
I think that's in the middle of the ocean.
Something is missing here. I'm missing something. What's going on? What's happening? Something's messed up with my database. Maybe? Okay. Ooh! Aha! I made a mistake. Okay, so what I really want is go away. So what I really want is insert into cities. You can't apparently insert apostrophes. That was my mistake.
Yeah,
Very silly.
Not do a slash on it. Backwards slash on it.
Whatever. It's fine.
Gotta escape it on escapes.
It's fine. There we are. So now I can show all the cities. There we are. Okay, cool. Let's quit. And now we're back inside. We left the Postgres database. We're inside the management pod for the database. This is where the app would run that accesses the database. And we can exit. Cool. Let's go ahead and take a look at the pods. What's happened is that we have a couple of backup style instances here. And that's been created by the job. So one of them is, and they were both happening at the same time. So this is how so let me go actually to the documentation. Here we are. So we have installed it. We ran the installment, and then on the Getting Started page, here are the PGO commands. So what I ran in the script was PGO version, and then PGO create cluster. And then I also ran PGO show cluster. This is the step we're in right now. We are logging into the database. I just kind of want to walk through how the backup works. So for the backup, unfortunately, you cannot do this from the app pod. From the app container. It doesn't have PGO. It shouldn't. So this is, again, something where you create this as a user, as a database administrator, not as a user.
It's an operator.
Yeah.
It's a human operator versus a human user.
Exactly. So, and manually the command you'd run is PGO backup, which is what I did right here in the job template. I ran a shell command. Oh, I echoed my username and password too. You might not want to do that for security reasons, but I just wanted to do that as a sanity check. And then PGO backup my cluster right here. And I hard-coded that, in this case, just for demo purposes. And you might just want to hard-code that when you have a database with a name. So, but I'm sure but this can be configured. So what that does is it creates an instance. So right here, the name of my job is called backup. That's what this is. That's the job that I ran. This is a container that has the instructions, that has the snapshot of the database backup. And I kind of unfortunately named my job, so I should have named it backup job or something. So if I go ahead, logs, I go ahead and back up. Get. So now I get some cool information. So this creates a backup directory in /pgdata/mycluster backups. This is on the host path for Minikube, so that's actually a little bit tricky to show.
Right.
But
yeah, what's the volume mapping on that? I mean, is it so it's
It's using the default host path for the PVC.
I see.
Yeah,
Okay.
this is the part where maybe I can learn from you because I'm not entirely 100% certain
persistent
how
volumes,
that works.
Persistent volumes is where you want to go when you're not operating locally and you're actually in a cluster.
Right.
And I imagine they have.
So Minikube has like persistence here. It has PVCs right now.
Mm-hmm. But it also depends on how you.
Right there, and they're bound, and they use a default.
Oh, looks like
default host path. Yeah.
Okay.
Yeah, exactly. So once I kill my Minikube instance, we're down, but that's the case if you bring down your Kubernetes cluster as well. But the documentation is a little sparse on exactly how to set up PVCs to configuration, which is something that we might have to do.
Well, with the databases, it's one of the most important parts of
right.
How does the data get persisted so that
where does it go?
If workload goes away, data does not.
Yeah, so what it says in the documentation is right here, manual installation. They have a script called create persistent volumes,
Mm-hmm.
and that will create persistent volumes in a place called /data. So if you ran this in your very own, maybe you have a Kubernetes cluster built from scratch, you would need to run these commands. You need to make this directory, and then you'd need to run.
Let me see their Helm chart.
Yeah.
Let me see their instructions for that. Yeah. Oh, they don't talk about what options they have in the Helm chart?
No.
They just say how to use it?
Yeah.
Oh.
Yeah. Yeah.
That would give me some. Usually, if you look through that and the options that they have, they'll tell you, like, if you want to do PVC, you do this,
Mm-hmm.
and you reverse that, you'll see how they're hooking it up.
I didn't actually try the Helm chart because
it's worth a glance just to see how they're.
I couldn't make the Helm chart work initially
when
I first did this, and also I just wanted to see the manual installation.
Sure, but just for the perspective of even understanding how they are doing it, this sometimes reveals how the Postgres is getting installed into the Kubernetes world and if they're looking up things correctly or not.
Right.
And that would be the first question, to make sure that they have PVCs down correctly and are parameters.
So that's a good place to look. Cool. I can follow up on that. That's awesome. And then, but right here, and this was confusing to me because I thought I needed this, but it can literally the basic installation uses the default operator configuration settings. These settings assume you want to use host path storage on your Kubernetes cluster for database persistence.
Yeah,
so that is something that Minikube apparently comes with.
Yeah.
But we might want more control on that.
Well, in production, I don't think you would ever be using host path. You'd be doing some kind of other persistent volume type.
Right. So with this script, you can create persistent volumes in the place of your choosing.
Mm-hmm. Yeah, cool.
And so that's definitely a thing that they help you with, which is nice. And by they, I mean the nice people at Crunchy Data. Cool. So let's see. I have here my backup snapshot that has completed. It's a backup container. It's there. And now I can use that to back up my cluster database. But before I do that, to rebuild the backup, but before I do that, I kind of want to go and no, it's fine. I already put stuff there for the demo purposes. Let's go ahead and create the backup. The way to do that, unfortunately, what I need to do is, because now I don't have a handy pod to exec into right now. So what I'm going to do is some port forwarding. Let's see, I still have this, and my Mac terminal is broken, and if I tab into it, it will literally not open in the same place, which is super sad. I have no idea how to fix it. Yes, thank you. I meant CD into it. Okay, so let's go back to my notes so I can quickly set up the port forward. No, it's different. Okay. For the backup, we need to actually use PGO locally. Fortunately, I have that. Okay, but if I go run PGO version, actually, see, running into this again, if I run PGO version, we don't have an operator to talk to, so we need to hook that up.
Mm-hmm.
So I'm going to port forward to that. So I'm going to set that up for a second here. Give me a minute. Kubernetes port forward. So I'm going to go ahead and get the operator pod, which is right here, Postgres operator. And so I can use kubectl port forward this pod, and it listens on, I believe that was 8443. And there we go. So now we're talking to the Postgres operator. We also need to talk to the Postgres database, which lives, which is my cluster. It's this one. And that one listens on, oops. Forward. This guy. And I think it's 5432. Okay, cool. So now I can hopefully call PGO version. And I still need to specify some env vars, right? So I need to export my API server URL. This time I need to export it to localhost because PGO expects that to be set as an env var, which is a little complicated. Okay, so now it's giving me more errors in that I need to have the user certification specified. The demo comes with some keys and certificates that we can configure. Oops. There we go. So now let's see if we are talking. And we're talking. Awesome. So now what I can do is I can run all those PGO commands that I ran inside the container earlier. So we can go PGO show cluster. And there it is. Now we're talking. And now what I want to do, now I want to perform the backup, right? So let's go back up here and see. Here we have several backup ones. Let's try the most recent one maybe. Sorry?
I like when I figured stuff, how they broke this up and make use of it.
So now here we have a backup path. And what's really important for the backups, we need this path. In the instructions, it says, and this is something I fixed just yesterday. I was trying really hard to make the instructions work. Let's go back to getting started. Backup, create cluster, PGO backup. So we have run, the job already ran these commands for us. PGO backup my cluster. And let's go ahead and maybe show, when we already saw the PVC, actually PGO can show the PVC as well. So let's go ahead and do that. Takes a little bit. It's there. Almost there. Interesting. That is fascinating.
So status order calls.
I don't know what this is. Did I just create that with my call?
PVC? No, I think as soon as you say, what did you say?
Show.
Show PVC, that's what spawned.
Right.
Because that's LS PVC.
List PVC.
Yeah.
Gotcha. Interesting. So that's one of those.
What's the log?
That's one of those containers. Yeah, I'm just looking at it.
There are these little images that do these little commands. Oh, good job.
Okay.
Okay.
So there we are. So let's try running it again. This should work now, right?
I don't know how that guy operates.
I don't know. This is one of those containers. Yeah. So there we are. And so that's the folder for my cluster
You're waiting for
backups.
that image to spin up.
Yeah. Yep. Interesting.
Mm-hmm.
So that's unfortunate when the PGO show spins up the container first. Maybe the error should be should wait. So, although no, that is the error. Never mind. So, yeah, I guess
He told us.
I was just surprised.
You're
That's
just not
all.
listening.
It's all me. It's all me. It's my fault. So let's go back to this backup container, backup my cluster. And it gets a unique label because we keep running backup jobs every 5 minutes at this point, which is not something I would recommend. But here we have the backup path, and it's set to /pgdata/myclusterbackups. And you kind of need the second part of that file path to go ahead and create the backup cluster. So what's happening here is I'm going to run pgo create, again, just like I did for the original database, create cluster, backup DB. Now I'm going to use some flags. And I'm going to say the flag, and it's 3 flags, it needs backup path.
I'm not going to say restore.
This is just a name for a cluster.
Oh,
It's just restore DB backup. You can call it unicorn DB.
Right, but it's going to be the name of the new thing.
Yeah. Sure. So actually, in terms of, let's just go ahead and call it.
Restored or something.
Yeah, restored my.
Cluster clone.
Yeah. My cluster. How's that?
Yeah,
And
sure.
then we want to go ahead and say backup path
I see.
equals my cluster backups. That is that. That is from that list right here. This one.
How many dashes do you need there?
And then, oh my goodness, did I do that again? I keep doing that. It must be a, oops, hello, talk to me. Why is it? Okay, fine, just go ahead. Die on me, will ya? My cluster backups. And what I need to do here, according to instructions,
Let's find that.
is give that timestamp from that
Location,
container.
right.
Yeah.
It's up a little bit. There it is.
And right here, we can do either, but let's choose this one. Oops. Okay, we're not done. We need more flags. We need backup PVC, my cluster backup,
Gotta name it. Yeah. Whatever it's called.
and that's the persistent volume claim. The confusing thing is there are 2 persistent volume claims. My cluster has a persistent volume claim, and it has
There's the data directory for the database server, but then it makes another one for backups specifically.
exactly. So there's 2, and it is confusing. And this is a thing I fixed in the demo documentation yesterday, which was really nice. Everyone's been so nice about me being like, but I have one more typo. And so this flag secret from, it will not run without the secret. There we go. Secret from backup path, backup PVC are all required to perform a restore. It uses the same exact secrets that I set on the database initially when I created it.
That's the secrets of just the keys to the server.
Invalid cluster name format. Interesting. Must consist of lowercase. Haha. I can't use an uppercase.
No,
I did not know that. That's
Neither
cool.
did I.
But this is a very helpful error message.
There's some dashes there.
Let's do that. Ta-da!
Yay.
All right. let's go ahead and get those pods and see if we can find the backup cluster. Right here it is.
Start.
And it is basically running. So let's get the logs on that. Look at that. That's a lot of logs. Oh my goodness. What? Okay. Let's get those pods again because I will never see them again. And it is running. How about we go ahead and exec back into my pod and try and log into the restore database and see if Gwenstown exists in it.
Exists at 0.1.
Yep. So, actually, let's just do the reverse search. Exec. Okay, and then PSQL-H. And my service is, in this case, it's not my cluster, it is restored my cluster. We're still in the demo namespace. And there we are. Okay, and then we want select all from cities. And there it is! And this is a backup database, and it totally works. So what we might want, so what you might want to do instead of like port forwarding everything, because that's annoying, is set up a database operator pod on your Kubernetes cluster that is easier to use, right? So and then from there,
you got a lot of options for it, but they have all the pieces that you need. So
Yep.
it's good.
yeah, so you can configure this. You don't have to mess around with so many port forwards, but this is a quick and dirty way of getting in there and using PGO. So in a way, now you've kind of seen two ways of using PGO. One directly from your machine and one from inside the cluster. Yeah, so the secrets part is actually kind of cool. You can go ahead and you can let PGO show the secrets. Let's go ahead and quit out of Postgres and exit from my pod, and you can actually run PGO show secrets. This is not where I want to be. Like this. Again, this is kind of the reason that you don't want your user to have PGO.
All the secrets.
All the secrets.
You got all of them.
All the secrets. And you can also go ahead and kubectl get the secrets. Oops. And there they are. We got a lot of secrets because you have, as you can see here, we have a Postgres username, we have a primary username, we have a test username. And they all have secrets right here. And then the restored cluster has the secrets. If you actually go in and look at the secrets, they're the same.
And this is all generated by your init script, right? Is that correct?
My init script, all my init script did was create a
The backup?
it ran a pod with an init container that set up a database, and then it kept a Postgres container running.
So did all this automatically get set up as the function of starting the Postgres server?
This gets set up as a function of starting the database.
Yeah.
Yes.
Yeah.
Yes.
So
So in a way, the init container, yes, my init script did that. But that's just because it instantiated a database.
Sure. Still has the same problem.
Yeah.
Feature.
The restore, the backup job doesn't do any of this because the restored database only starts existing once you actually go through the steps of manually restoring.
Cool.
So,
Cool beans.
yeah.
Thank you, Gwen.
So this is the crunchy data Postgres operator for Kubernetes.
Yeah.
Da, 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 da.